Hi, my name is Carolina Mingasarian, and I'm joined here today by a special guest who will be learning the phases of the moon with you. In today's video, I'll show you how to visualize the phases of the moon in a fun experiment using Oreo cookies. In this experiment, it will also help you understand the connection between the phases of the moon and the solar and lunar eclipses. Alright, so for this experiment, you'll need 16 Oreo cookies. It doesn't matter which kind you use. You will also need a single toothpick. You will need 2 pieces of 11 by 14 paper, and you will need 1 pencil. All right, so now we'll take 8 cookies out of the 16, and what you'll have to do is twist the cookies and open them up like this. So one side is plain and the other side has frosting. You have to carve out the frosting out of the cookie with a toothpick. There are 8 phases: the new moon, which is the plain cookie. Then we have the waxing crescent, the first quarter, the waxing gibbous, the full moon, then the waning gibbous, last quarter, and lastly we have the waning crescent. You'll have to organize these cookies from new moon all the way to waning crescent and place them on a piece of paper in a straight line. All right, for the second part, we're taking 8 more cookies, but we're gonna do something different. So first, before we carve out the cookies, we will have to draw on a piece of paper. So draw a circle, label it Earth, label the South Pole sunrise, the North Pole sunset, the East noon, and the West midnight. This will show the time of day on Earth when the Earth is in that certain position. After you're done with that, you will have to draw arrows on the right-hand side to represent the sun's rays. So we'll see where the light hits it, and that will shade the earth to show the shadow. Now it's time to carve the cookies, and for this part, they're only going to be halves. You're going to carve them right into halves. This is exactly how you're supposed to carve that cookie, and I will explain why in the next step. All right, so this is the perspective from outer space. Unlike this other project, got a little messed up, but this project is our perspective from Earth on the moon. So, making sense of this means that the moon is always 50% illuminated in outer space. So the sun always shines on it and it's 50% illuminated. So the phases of the moon, like this, are caused only because of our perspective from Earth on the moon. Now let's label both the first experiment and the second experiment. Number 1 is new moon, number 2 is waxing crescent, number 3 is first quarter, number 4 is waxing gibbous, number 5 is full moon, number 6 is waning gibbous, number 7 is last quarter, and number 8 is waning crescent. Alright, so looking at our piece of paper with our outer space visual right here, we can see that the new moon right here is between the Earth and the sun, but it's part of the usual cycle and usually nothing interesting happens. This is because the new moon and moon in general, the moon in general has a tilt of 5 degrees when it orbits around the Earth, but occasionally the moon aligns directly between the sun and the Earth, and so when the moon is in between the sun and the Earth, we call that a solar eclipse, because the moon casts a shadow on the Earth's surface, making it look like the sun has been covered up and that it's nighttime. This means that right before the solar eclipse occurs, the type of moon we see is the new moon. On the other hand, we have the full moon right here on our diagram, and it looks like it would be covered up by Earth because it looks like it's right behind it. But, as I mentioned before, the moon has a 5-degree tilt when it orbits around the Earth, so the sun is always able to illuminate it, meaning that sometimes we don't get a normal lunar cycle, the moon cycle, and sometimes we have a lunar eclipse. A lunar eclipse is when the moon is positioned directly where the Earth is between the moon and the sun, meaning that the Earth casts a shadow on the moon, creating the moon to be a slightly darker color. Usually it's a reddish kind of color. This means that before the lunar eclipse, the moon that we see, the phase of the moon that we see, is the full moon. Alright, so to sum it all up, phases of the moon occur due to the Earth's perspective on the moon.
The moon is 50% illuminated and constantly maintains a dark side.
Both of the diagrams contain the phases of the moon, except one is from outer space and the other one is from our perspective on Earth. This means that phases of the moon, as I said before, are caused only because of our perspective from the Earth on the moon. Also, the lunar and solar eclipses happen because of the phases of the moon. Sometimes the moon blocks the sun because it ends up directly between the Earth and the sun, and sometimes the Earth blocks the light of the sun to the moon. So sometimes the moon appears darker, which is a lunar eclipse. Alright, thank you for watching, and I hope you learned something.
Yeah, I did. Thank you so much.